Hey, welcome all. Today we have an exciting call. This session, I started a lot of my development. When I remember my developer days, I used to be a mobile developer working on Xamarin. And yeah, I think this is really close to my heart. And thanks a lot, Shane and Neha, to agreeing to come on our community call to present about MSAL, single sign-on Android apps. This is really exciting for us. Like always, the call gets recorded. So we are going to record this call and we're going to host it on our YouTube channel. You can go to our YouTube channel, just go to that link, aka.ms m365pnp/videos. You will be able to see all our videos. We do this monthly call and you can follow us on Twitter, Microsoft 365 Dev and Azure AD to get updates on what's going to be the next call. We do a lot of exciting calls. The next call is going to be on December 15. With that, Neha, who is our product manager here, and Shane is our principal software engineer. Off to you, folks.
Hey, hi everyone. I'm Neha Goel. I'm a PM on MSAL Android team, and I'm here joined with Shane, who's a lead principal engineer, and we are going to co-present this topic today. So on our agenda today is overview of MSAL Android. What exactly is MSAL? And then we will dive deep into how you can enable SSO, what is single sign-on, and what are the ways to enable SSO. And then Shane is going to talk about what is proof of possession and how you can actually use proof of possession to protect your access token. And then we will open the slot for Q&A. So let's just dive in. Well, MSAL Android basically enables you to acquire security tokens from the Microsoft Identity Platform to authenticate your users and access secured web APIs. So basically, when you're using MSAL Android, you do not need to directly use the OAuth libraries directly and write a code against the protocol in your application. It maintains the token cache and refreshes the tokens for you when they are close to expiring. You don't need to handle any token expiration or token management on your own. And these are some of the list of features which are supported by MSAL Android, SSO with custom browsers and brokers, Azure AD-B2C accounts, brokered auth, single and multi-account mode, logging, and global settings. Today, we are going to dive deep into how SSO works with browsers and brokers using MSAL Android. So what exactly is single sign-on? You guys might have already been using single sign-on. You might already know single sign-on. This is like a really great feature in identity which was developed and is very, very convenient for end users. So basically, single sign-on allows end users or employees to only enter their credential once and have those credentials automatically work across applications. Now, what MSAL does for you, MSAL works with a broker component which gets shipped via Microsoft Authenticator app, and it provides you device-wide SSO across all applications. Some of the biggest problems which you can solve through SSO is basically there is going to be less password management, which means less prone to human error. And it makes your system more secure and decreases attack surface. It also improves overall efficiency and productivity by improving the end user experience by just letting them enter their password once and then just forget about it, and then apps will be magically signing them in. Now, apart from just the end user experience improvements, it also saves enterprise quite a lot of IT team time and money by not letting them do a lot of automation, integration, and actually password resets, because passwords are basically just not being entered too much, so there is less probability of forgetting the passwords or losing the passwords, things like that. So how you can enable SSO in your application using MSAL Android? There are two main ways through which you can achieve SSO in your application. So first, of course, your application should be using MSAL. and then through broker application. So broker application is a component, which is a headless application, by the way, and it gets shipped via Microsoft Authenticator application. This Microsoft Authenticator app holds the broker component. And the second way you can actually achieve SSO is through the default browser and using the cookie jar. So we strongly recommend you to use broker application for getting the benefits like, as I mentioned, device-wide SSO. It also provides you account management experience and conditional access. Although it does require your users to download additional application, but then it only happens once. So what exactly is broker and how SSO via broker is achieved? Well, as I mentioned, the Microsoft Authenticator Broker is a component that's included in Microsoft Authenticator app. And Microsoft Authentication Broker can be utilized to provide device-wide single sign-on. And it also helps you meet organizational conditional access policies, and integrating with broker can provide you benefits like conditional access, device-wide SSO, managing Intune policies, etc. So the Microsoft Authenticator app can be installed by the end user anytime through the Google Play Store, basically. So there are three major steps, which we are also going to watch in a demo today, which we need to actually going to focus on while integrating with broker. So first, we would need to generate a redirect URI to enable the broker, and then configure our MSAL application to use broker. There are some config values which we would need to update, and then we are going to verify our broker integration in the demo. And the second way is, of course, is when your application is not using brokered authentication, or you do not have a broker application present on the end user device, then the other way of actually achieving the SSO is via system browser or also web view to attain the SSO. Now, let's just go into the demo. Give me just 1 second and I'll share my screen again. So as I said, to enable SSO, you need to update configuration settings of your app, and we are going to need two main things: redirect URI to enable broker, and value for authorization user agent, which is going to be defined in the config file of your application. So I have a demo test application for demo, which I have already downloaded here. I have already downloaded our authenticated app where our broker is hosted. And let's just dive deep. So first, to get the redirect URI, you would need to sign into the Azure portal and select your application, go to the authentication blade and click on add a platform. Select Android as your platform of preference here, and you would need to provide your application's package name. And before this step, you would need to generate a signature hash using command line via key tool. I'm going to provide my package name here. And I'm also going to share my signature hash. And once I click on configure, it has provided me the redirect URI. Basically, the redirect URI is the combination of my package name and the signature hash, which I generated using key tool. And this is the configuration file which it has generated for me, which you can just copy right here from here and provide all these values here and paste it. So authorization user agent set as default means if there is going to be a broker, there is always going to be like P0 broker would be the preferred option for any MSAL enable application. Every time when a broker is present on the system, on the device, MSAL applications, all the acquired token requests are going to go through the broker application. If broker is not there, then you can actually explicitly use values like, for example, browser or web view if you want to make browser as your default or web view as a default. So I'm going to go on the demo app here. So we have config file selected as default, and I already mentioned that I have downloaded Authenticator app. So I'm going to click on, as you see, there is no account selected here. There's no account added here. Now I'm going to click on acquire token. The UX here is actually provided by the broker application. You see it is a little bit different from the browser, system browser or default browser. Now, wait, what happened? Now I'm going to provide my credentials. So we just got our first token, and the token request went through the broker. Now let me share the device state with you. I am going to show you settings and accounts. So whenever you use broker for authentication, that account which I used to sign in got added on the device level account management. And that is what helps us to basically share and get the device-wide SSO. And if I show you how does the Authenticator app looks like, and if I click here on the sign in, you will see this is already coming into list of the accounts, the account which I just used in my application. I never added this account explicitly here. So this is what the advantage you get for the device-wide SSO. You will get the account already in the account list to for the end user to select and then authenticate. Now, what happens if I go ahead and delete the Authenticator app? What would be the scenario in that case? So let's just try that. App info, and I'm going to uninstall the Authenticator app here, okay? I guess it emulator restarted. Well, now we do not have an Authenticator app here. Let me just go to the test app. And now I'm going to select browser as my preference for signing in here to achieve SSO. There is no account selected here because I deleted Authenticator app. So therefore, all the accounts associated with the Authenticator app got deleted from everywhere because broker is what is managing accounts across device. So let's just click on acquire token. So now you see there is a different UX you're seeing, and now the app redirected me to the default browser, which in here in this case is Chrome. And now I'm going to sign in again and provide my credentials. And we just signed in using the system browser, basically. So the system browser actually maintains the cookie jar. And if I go back and, for example, if I try to open Outlook, well, it has kind of already signed me in somehow using the same account which I used for signing into my test app. So this was just the demo for enabling SSO on using your system browser and the broker application. So there are a few things which I would like to highlight that what you need to keep in mind when we are talking about broker and what is the impact of broker overall. So whenever a broker is installed on the device, all subsequent interactive token requests, like for example, calls to acquire token, are handled by broker rather than locally by MSAL. And if, for example, broker was not installed before and I would have gone through the system browser first, and then I would have downloaded the broker, basically SSO state previously available to MSAL would not be available to broker unless I have actually used broker for authentication. So it is going to ask me to sign in again. And basically installing a broker doesn't require the user to sign in again, because you saw that the moment I actually signed in using my test application by default, using the same account, I got signed in into the broker. And we saw that once I removed the broker hosting application, all the user information in the account was deleted from my test application and also from the device. So this is what we had the demo for SSO today. And are there any questions?
I see one question in the chat. It says, any way to change the redirection page for authentication to an internal company page or usage company branding instead of out-of-box MS?
Okay.
I believe there is, but I'm going to poke around here and see if I can find a link to the documentation. Unfortunately, of course, when I search for sign-in customization, I find everything related to Azure Active Directory B2C. But I believe that there is actually support as well for just standard organizational customization of the sign-in UI. But I will dig it up for you guys here, and I'll post it in the chat when I find it.
So I will hand it over to you, Shane.
Sure. Yeah, I mean, there was a couple other questions in the chat, so I'll just briefly mention them. The broker, the broker does do what's called device registration. So basically what that means is, when required, the broker will, prompt the user to register their device. The device then becomes known to Microsoft. And we actually, an Intune or another MDM service can, report device health status relative to that device. We also keep track of Intune app protection in the same way. We know which applications have been installed on a particular device and which applications have had Intune app protection policy applied to those applications. So a lot of things are sort of bound up in the broker. One of his core responsibilities as well is authenticating the client applications. So we talked about the redirect URI that you need to create, and the redirect URI is based on the signature of your application. And so using that signature along with the package name, the broker can actually authenticate your application, which is exactly how we do that for things like Intune app protection. Anyway, so there's quite a bit to the broker. Feel free, if you got any questions, to throw them in the chat. I'm going to talk a little bit about proof of possession. This is that we have a current implementation that's in preview with the MSAL Android library, where we have also the implementation completed within AAD v2, so Azure Active Directory and the v2 endpoint. It's based on a specification that had actually expired a little while ago, and now that specification has been reincarnated as a new draft. And so you may see the specification referred to as demonstration of proof of possession, or DPoP. So this is very similar to that spec. It doesn't follow that spec to the letter because, again, it's never really moved out of its draft mode, but it's something that Microsoft is interested in pursuing, or internally for our own users of Office 365, and then we think it also has value for external customers. Basically, with proof of possession, we generate an asymmetric key pair on the client, and where we ideally are generating that key pair in hardware-backed storage. That private key is held in that hardware-backed storage, and we actually take the public key, and when we make our original access token request for, let's say, MS Graph, we provide along with that request the public key. And so when we get back our access token, that access token contains that public key. And then what we do is we actually take that private key, we create a new JOT token that wraps the original access token that was returned, and we actually sign that JOT using the private key. So now I have an envelope signed with the private key, but inside the token is the original access token with the public key. And so our server software has also been updated to validate this kind of token. Now, why are we doing this? We're doing this because we want to be sure that when you've got an access token, that it's actually being sent back to a resource server by the client that it was actually issued to. The tokens today are bearer tokens, which means that if you are literally the bearer or the holder of the token, the service is like, well, you have the token, so therefore you have authorization. And so there's not a lot of protection in terms of token exfiltration. So in other words, if somebody was to intercept a token, if a malicious app was to take a token and forward it to a different endpoint and try to use it from that endpoint, it becomes a situation where bearer tokens are a little bit, they have some weaknesses. And so, we're looking to, increase the overall security posture, and we see DPoP and proof of possession as a way of doing that. So partly what's interesting about the PoP token, in addition to the binding using the keys, is you can actually, in that envelope, you can actually add additional, address information. So when I create that wrapping token, we actually ask you to provide the HTTP endpoint that you want to send the token to, like the full path, as well as the HTTP verb, which means that that token, even if it's intercepted, it can't be replayed for just any purpose, right? Today, access tokens tend to include all of the scopes which the user granted the client application. In this case, when the client actually creates the JOT token, and again, MSAL will look after all this for you. You don't have to do anything. MSAL will generate the private key. MSAL will make the request for the original access token. It will create the signed JOT. There's nothing you have to do there. We'll do it all. But the additional addressing adds another sort of layer of protection, because it's not a situation where, I've submitted this token to do this operation, and that's the only operation that it can perform, right? It can't do other operations against other endpoints that are part of the same API. So there's some pretty substantial benefit. In addition, it enables some pretty interesting scenarios where you can model your services somewhat differently. So you get to a situation where you could potentially have multiple physical services that actually use the same app ID. So effectively, they have the same audience. So in other words, the audience for all of these things could be service one, right? So service one, the tokens are accepted here. Service one tokens are accepted here in this physical endpoint. Service one tokens are accepted here in this physical endpoint. What's interesting about this is now your client application only really has to request one access token. But what's also interesting is that if those different APIs have different functionality, again, by having that addressing in the envelope JOT, you can say, okay, I can send it to the physical endpoint 1, but physical endpoint 1 can't forward it to physical endpoint 2. So it's kind of, you get some very, very nice capabilities that come out of this. And by having proof of possession, we also get to a situation which is better for Microsoft in terms of the cost of running the business, and is also better for you in terms of reliability, which is basically with proof of possession, we're more comfortable extending the access token lifetime. So default access token lifetime, historically was an hour. With proof of possession, we feel comfortable, and obviously this is something that customers will have input on. Extending these access token lifetimes. Why is that good? Well, if an access token is expired and for whatever reason the security token service is inaccessible, you're not going to be able to refresh that token, and that application is not going to be able to do what it was supposed to do. So there's sort of like a huge bucket of benefits to getting to proof of possession. So anyway, I will dig into this a little bit. I'll be ready to answer any questions you have, but we'll go to the sequence diagram here, and I'll walk you through kind of the steps. So I spoke to this, but this is actually a picture of what the flow roughly looks like. So you're actually invoking MSAL, and you're making a particular request for a particular authentication scheme. So instead of making a request for a bearer token, you're making a request for a PoP token. MSAL is going to check to see whether or not that key pair exists for your client. If it doesn't, it's actually going to go ahead and generate that key pair. It's going to then take the public key, and it's actually going to make the token request, as I said, with the public key. It's going to get back the access token with the public key as a claim. It's then going to cache that result. So now that access token is in the cache, and you can use that same access token now to generate multiple PoP tokens. So the envelope, the message, the original access token that's going to be embedded in the wrapping JOT gets reused, but each JOT is per request, right? Because that, again, that JOT is targeted at a specific endpoint with a specific HTTP verb. So you're going to be able to, when that request comes in, we'll generate that envelope using the values that you provided us. We'll sign it with the private key, and then we'll return it back to you so that you can actually use it to make your API call. Any questions on anything here so far? I think there was a question about for iOS. So for iOS, this is work that's still in progress. Right now, just to give you guys a sense of where some of this is heading, we already use a protocol very similar to this, and some of you may have heard of this protocol because it's documented for Windows. So mobile uses the same protocol, which is sometimes referred to as the primary refresh token protocol. And we use the same proof of possession approach to ensure that those sort of those primary refresh tokens, which are the ones that enable device-wide SSO, are bound to a device today. And so we're doing some additional work to be able to assert information from the device about, what model of the device is this, and is this private key actually stored in hardware or not? And so there's some work going on the PRT side, and once that's finished, then we'll be able to return to some of the more access token focused work. But obviously, this is very exciting for us and very exciting for hopefully for you folks, because this is I feel like something where we're actually going to be able to make a difference from a security point of view for probably in a fairly big way. So for me, it's exciting, but I geek out about this kind of stuff. I'm just looking here for other questions. Yeah, I mean, I think in general, our goal here is, it's never straightforward to adopt a new, authorization protocol. As I mentioned, we're not just making changes in client applications. We have to make changes in, APIs, right? So in these various services that are out there have to also be updated to understand and be able to validate correctly PoP tokens. So this is not something that just we flip a switch and, we're all able to start benefiting from. It does involve quite a bit of work. But we think that the promise of this is very exciting. Is the new PoP token generated for every single request? It depends basically on the HTTP endpoint and verb that you pass in. If we already have one, that we generated, I think the validity of those tokens is relatively short. So I would say you can think of it as being done on every request. There may be some scenario where it will take one from the cache, but those JOT requests are kept to a very short lifetime, much less than an hour. I think it's like 10 minutes. Basically just the amount of time to deal with clock skew between the client and the server. Yes, so the work it has been done already to validate the PoP tokens. So the MSAL, our MSAL server team partners, and you'll have to forgive me because I'm a little bit unfamiliar with the various acronyms they use for their libraries. So I think it's ON there's the ON packages that we have for token validation. So I believe they've been updated at this point to support validating PoP tokens. Okay. Should we go to I think that's basically it, right? Do we have another slide there, Neha, or I think I may have already spoken to this. Yeah, I think I already spoke to that. Yeah. So any questions on that or anything else? And I'm sure Neha and I are willing to field any kind of questions you have relative to MSAL Android, but probably MSAL in general. We'd be happy to take a crack at it.
There is one question. Are you making the API side code needed to validate the PoP?
Yep, we are. And I think the answer is yes, we will do it for more than just .NET. So I think right now from a middleware point of view, we support Node/Passport. So I believe there's something there that's coming along. And I think in general, there's an effort that I'm involved in, which I'm not going to talk too much about, but like there's an effort involved in trying to figure out how we bring some of the things that we're doing with middleware today to proxy servers. So I think like in general, it's difficult for us to support every language and framework out there. Our team can't necessarily scale to every language and framework that somebody might want to use, but we do think we can light up identity scenarios using reverse proxy solutions like Nginx and others. I think there's a new Pingora one that's written in Rust from Cloudflare and others. So I think if we're able to do that, that will be a benefit and hopefully enable us and enable you to, have a little more flexibility in what languages and frameworks you choose to work with, since you'd be delegating responsibility for things like token validation to the reverse proxy.
There's another question about a .NET Core daemon console application calling a protected web API. They have put a sample out there. Are you asking for, if we're going to update that sample? Is that the question?
I think that like the reason why some of these things are marked as not recommended is, again, like we're trying to figure out like what is the status, and this kind of goes to the next question: what is the status of the public specification, and where will things land? This kind of why it's still in preview, in Android land as well. Like it's very possible that we will make changes here, and we are still, I think there's still some difficulty in terms of getting broad industry support for Depop, and so that work is ongoing. I think that if you and your the organizations you work for, or whatever your relationships are, if you have any ability to influence these things, feel free to try to do so. I mean, I think personally, I feel like this is a very useful security enhancement. But I think it in some ways it's how do I say this? I think identity is not static. Things are always moving. Things are always changing, and I think we've seen some evolutions in the industry over the last few years that actually touch on some of the things that we talked about today. We have Google, who's very heavily invested in trying and encouraging folks to do authentication using the default browser. But of course, if you're doing that, then some of these capabilities become more difficult to implement. And I think that there has been some feedback that's been given to Google, and certainly there's been some feedback given to Google by me and by some others, that who are concerned about delegating an authentication flow to an external application like a browser. It's not a dedicated channel for authentication. It's not something that's being provided by the operating system, like WAM or like the Android account manager. So I think that there's some things here that are kind of still in flux. But I think like this part of like what we want to do here is share this information with you guys so that we can get a sense of how enthusiastic you might be about things like proof of possession, and sort of see if we can build some kind of support for getting this to a place where there is more interest in industry adoption and more push to get this kind of thing over the finish line. And I wouldn't call this either. There's no magic bullets. So there just isn't. So what we talked about today is relative to tokens. There's also similar discussions about how to protect cookies. So it's again, there's no magic bullet here. I'm just going to check the chat here for questions.
Sure. Jeffrey has a question, and I also see Harry's hand is up.
Yeah, go ahead, Harry.
Yeah, you said about the proof of possession that there's the audience inside the token, that is the one defining that who can access or use the token.
Yes, that's correct. So you can what this sort of enables. So I don't know how clear this is to everyone. When you use Microsoft Graph today, Microsoft Graph, when you hit the main Microsoft Graph endpoint, effectively you're hitting a reverse proxy. It takes those requests and forwards them to different backends. But you have one audience in the token. It's Microsoft Graph. But in the case of Microsoft Graph, you have a physical reverse proxy, a place where you're sending that token. You can imagine with proof of possession access tokens that you don't actually need the physical reverse proxy anymore. I can define one audience. I can have multiple separate backends that have different functionalities. So imagine microservices, for example. So I've got one or more microservices set up that all are using the same audience. So they all accept the same token audience. But what you can do is you can say, I can target the specific PoP token to a particular endpoint because I put the addressing information in the envelope. And part of validating the PoP token is to say, yeah, the PoP token is valid, and it was sent to me and to this specific endpoint, and so therefore I accept it. When it's received by that first endpoint, because that endpoint doesn't actually have the private key, it can't just take that token and forward it. right? So it can't take that token and forward it. And so there's sort of like a 2 layers of validation that happens, right? You have to validate the inner access token using the signing keys of AAD, and then you have to validate the envelope using the public key that was contained in the inner token. And so if you don't have the private key, you can't forward that token. So it enables you to get to a place where you need fewer access tokens to enable scenarios. And so there's like the security benefit, and then there's what I sort of sometimes refer to as like the kind of the cogs, or the cogs benefit. And as I said, I think there's a reliability benefit as well, which is kind of attractive to me.
Yeah, the security side is huge on that one. Who is giving the private key that you use in the envelope? Like, can we give it ourselves? Is it always Microsoft?
Right now, MSAL has done it internally, but this is like something that I think we would be open to discussion about. We have some protocols, that are proprietary protocols internal to Microsoft that use, again, something similar, where we do accept a private key that's generated outside the authentication library. So it's not outside the realm of possibility from my point of view. We're just trying to simplify some of these things for customers by handling it for them. The other thing, it's nice for us from a conditional access point of view is, if you give us, if you point us to a private key location, or, we don't necessarily have the ability to like know how the key was generated and what, and under what sort of circumstances it's being, or how it's being protected, right? So when we want to make a policy decision, it becomes a little more challenging because, we don't necessarily know, was this key pair generated in hardware, and what was the hardware exactly, right? So if you're a very high, if you're a high security sort of customer, pharmaceutical, government, so on and so forth, you may literally care, like you may want to know, like you want to have an attestation from the exact physical device, meaning you might want to actually have attestation at the chip level to know where the private key is stored. But this is getting a little bit more kind of complicated here. But yeah, you can see a scenario where that'd be interesting.
Yeah, because I was thinking like the certificate-based authentication that came to GA at Ignite, that would be like a perfect place to get the customer's own keys, the public and the private keys, like connect them.
Yep.
This one, if it's possible. So
yeah, I mean, I think it's like if you see things like, one thing I'll freely acknowledge is that Microsoft's a big company. And sometimes we don't always see the opportunities to connect the dots ourselves. So feel free to help us, right?
Always welcome.
Yeah. That's the reason I opened my mouth. So I will send
I
you a
appreciate
message about this when I had some ideas.
Yeah,
Okay.
awesome.
Thank you.
Yeah, thank you.
Thank you, Harry. Neha has put in a question. How do you learn about MSAL or identity-related concepts for your application scenarios? If you could probably help us answer that. We're doing a lot of changes. We are trying to bring in new stuff. So this kind of information would really be helpful.
Any other questions? I'm just looking through the chat here. I saw a question from Jeffrey. Jeffrey, I don't know the answer to your question, but I can, if you email me, I can put you in touch with somebody who would be able to answer your question.
He's also asking if there's a good example that you could point to.
Yeah, I mean, the same thing. I will, if you send me that with both those asks, I can connect you with the folks on the .NET team who are looking after those things. You may have already run into Jean-Marc. I'm very likely to send you to Jean-Marc. So anyway.
All right.
I put my email, sorry, at the very top of the chat, but I'll type it here again here.
You can go to our YouTube channel. Just go to that link, aka.ms m365pnp/videos. You will be able to see all our videos. We do this monthly call, and you can follow us on Twitter, Microsoft 365 Dev and Azure AD to get updates on what's going to be the next call. We do a lot of exciting calls. The next call is going to be on December 15.